Any permutation of a specific set can also be a product of cycles of the same set. In this case here, we have S8. So we have this cycle here because if we have the expression or the notation using parentheses in this exact order, we have a cycle of 1, 4, and 5. Okay, but doesn't mean that it only contains 1, 4, and 5 because these are all in S8. That would mean that other elements such as 2, 3, 6, 7, and 8 are just mapped to themselves. That's why we only have this as our notation for our cycle. This is also true for the rest. Now, to determine the permutation in S8 that is a result of the product of these cycles, I could show you here two different methods. The longer method, of course, before I will present you a shorter method, just an analysis. This for you to compare and of course to help you really understand how do we solve for the permutations here. Now, let's start with the longer method. That is when we are going to come up with the permutations of these cycles. So since we have 3 cycles here, we're going to have 3 different permutations as well, multiplied with each other. So for 1, 4, 5, again, these are all in S8. So 1, 2, 3, 4, 5, 6, 7, 8, right? For 7 and 8, for the second cycle, still 1, 2, 3, 4, 5, 6, 7, and 8. And for the last cycle, still 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Now, for the first cycle, 1, 4, 5, that means that 1 is mapped to 4. Okay? And then 4 is mapped to 5. And then 5 is mapped to 1. That's the idea. And since this is a cycle, all other orbits, because this idea of 1, 4, 5 is actually taken from an orbit with at most, more than one element. To make this really a cycle, all other elements should be mapping to themselves. That means 2 is mapped to 2, 3 here, 6, 7, and 8. Okay? Now for the second cycle, 7 and 8, so 7 is mapped to 8, and 8 is of course mapped to 7. And the rest, 1, 2, 3, 4, 5, and 6. And for the last, we have 2 is mapped to 5, okay? 5 to 7, and then 7 to 2. And the rest, 1, 3, 4, 6, and of course 8 here. I hope that it's understandable or readable rather. So you have here 8 is mapped to 8. Okay. Now, of course, from here, we can now establish a certain permutation as we are multiplying all of these permutations from the 3 different cycles as we move from your right to left. So the permutation is still in S8, 1, 2, 3, 4, 5, 6, 7, and 8. And again, this is a longer method. Later, I'm going to share to you a shorter method. So we'll start from this. 1 is mapped to 1, 1 is mapped to 1, 1 is mapped to 4. Okay? So for 2, 2 is mapped to 5. Here we'll move to 5, map to 5, and 5 is mapped to 1. In short, 2 is mapped to 1. Okay? Next, 3 is mapped to 3, 3 is mapped to 3, 3 is mapped to 3. 3 followed by 4 is mapped to 4, 4 is mapped to 4, 4 is mapped to 5. Then 5 is mapped to 7, 7 is mapped to 8, 8 is mapped to 8. So that's 5 mapped to 8. Next, 6 is mapped to 6, 6 is mapped to 6, 6 is still mapped to 6. Then for 7, that's 2, 2, and 2 here. Finally, 8 is to 8, 8 to 7, 7 to 7. So this is now the permutation in S8. That is actually a product of the given 3 cycles. We have the 1, let me write here, 1, 4, 5, the cycle of 7 and 8, and the cycle of 2, 5, and 7. Okay, this again the longer method. Now, I would like to present to you a shorter method for this. So let me try to copy the same cycle here. So you have here 1, 4, 5, 7, 8, 2, 5, 7. Let's see with this shorter method if we will come up with the same permutation. Of course, this is all in S8, so let me still have here. Of course, I'm gonna change the color now. Okay, let me have red. Okay, so you have 1, 2. No, I'm just going to use a different color. Let's just simply say black. Okay, and I'm going to place here a movie here a little bit. Okay, so this is 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so how do we show a shorter method just by analysis? Of course, the movement is still from your right to left in this case. So we'll start with 1. Since 1 is not here, understandably 1 is mapped to itself. So 1 is mapped to 1. Here, 1 is mapped to 1. And then here, 1 is mapped to 4. Okay? Again, let's do it again. So we'll start with 1 because we have 1 here. So since 1 is not found in this notation for a cycle, automatically means that 1 is mapped to 1, same as the second cycle here. So 1 is mapped to 1. Here, 1 is mapped to 1, and that 1 is mapped to 4. Let's do 2. 2 is here, so 2 is mapped to 5. Okay? Take note, we are now on 5. Again, 2 is mapped to 5. Here, 5 is just mapped to 5. Because we don't have the item here for 5. Again, 2 is mapped to 5, and then here 5 is mapped to 5, but here 5 is mapped to 1. Therefore, for the 2, this is 1 here. Okay, even if we touch 5, the first value that we tried here is just 2. For 3, 3 is mapped to 3. 3 is mapped to 3. 3 is still mapped to 3. That's why it's a 3 here. Because there are no notations for 3 here. For 4, 4 is mapped to 4, 4 is mapped to 4, and 4 is mapped to 5. Next, 5 is here. 5 is mapped to 7. Take note, we are now on 7. 7 is mapped to 8 because we have 7 in both sides. Again, 5 is mapped to 7, and then here, 7 is mapped to 8. But as you go from here to here, 8 is mapped to 8. That's why 8 here. Next, 6 is mapped to 6, 6 is mapped to 6, 6 is mapped to 6. Then 7 is mapped to 2. 2 is mapped to 2, 2 is mapped to 2. Finally, 8 is mapped to 8, 8 is mapped to 7, 7 is mapped to 7. See the two results using the longer method and the shorter method. Now, some of you would say, I'd like the shorter method, but of course you need an analysis for that. If you're going to use the longer method, you can even clearly see the proper movement than just thinking about it. So anyway, we have the same result, same permutation if you use the longer method and the shorter method. And this is the permutation that is the product of the given 3 cycles. Thank you very much for watching.